recent articles about the spread of bacteria, it has been found that bacteria can propagate even after they die. Let's cover some of the basics of bacterial transfer, discuss a recent study of bacterial propagation, then describe the unique patent formula of Goldshield and how it prevents these bacteria from propagating. The transfer of genetic material between bacterial cells by direct cell-to-cell contact or by a bridge-like connection between two cells is called bacterial conjugation. It is a mechanism of a horizontal gene transfer. Genes are transferred from one bacteria to another using their pilus. A pilus is a hair-like appendage found on the surface of many bacteria. The genetic information transferred is often beneficial by the recipient. Benefits may include antibiotic resistance, xenobiotic tolerance, or the ability to use new metabolites. Such beneficial plasmids may be considered bacterial endosymbionts. Other elements, however, may be viewed as bacterial parasites, and conjugation as a mechanism evolved by them to allow for their spread. One of the lesser-known facts about bacteria is that it does not even need to be alive to pass its genes on horizontally. Once it dies, the bacteria releases its entire insides into the environment, leaving little DNA packages around for other bacteria that happen to pass by. The act of bacteria literally reaching out, picking up DNA from its environment, and hauling it back into itself with its pilus was recently captured on camera for the first time. To make matters worse, both dead and alive bacteria can easily become airborne, moving to new locations and spreading their genes further abroad. Because of this, it is significant to understand how Goldshield can help like no other chemistry. As bacteria die and leave their DNA packages for other bacteria to reconstitute and propagate, existing chemistry simply cannot keep up with this regrowth. Our own studies show that after disinfection, ICUs were recontaminated with the bacteria within 3 to 4 hours at the same levels prior to disinfection. This creates the need for a persistent protection to prevent the regrowth of these bacteria. By using Goldshield, it actually disrupts this communication, as well as the transfer of DNA from bacteria through its mechanical and residual protection. Quite simply, Goldshield blocks this amazing bacteria social network. With Goldshield's complex chemistry, it penetrates the tension of surfaces, permitting the antimicrobial to bond and cover surfaces more evenly. This results in better efficacy protection, or a surface killing field. But here's where it's significant. Goldshield has a nitrogen compound that positively charges the surface. That draws in all airborne bacteria, killing them as they reach the treated Goldshield surface. This includes textiles, such as hanging privacy curtains. Since bacteria are all negatively charged, they are drawn to the surface where they are destroyed. So what have we learned? Unless there's a persistent residual protection, existing chemistries are outsmarted by bacteria and are at best a temporary fix. This is why Goldshield is dramatically different than any product on the market